Hello and welcome to the Dinosaw number 250, another 7 curious, interesting things I saw last week. So as ever, let's crack on. And the first one is emulating a fly's brain. Now we have mapped the fly's brain. We've also mapped a worm, a nematode worm. That's quite a simple brain. The fly is actually a big step on from that. Now we've mapped it, but we haven't actually connected it to doing stuff. And that's what Eon Systems have done here. So they've taken the 130,000 neurons that we've mapped in the brain. And then what we've done is then mapped on the 50 million synaptic connections from those neurons and connected them to an actual fly simulation. So legs and smell and all that sort of stuff. So as you can see from the simulation, if you put some banana, a virtual banana, and attached it to the actual virtual brain, it will figure out what to do, which is a bit bonkers. So yeah, that's the connectome is the big thing that they've done here. So that's interesting. Now, if you're thinking, does this thing have consciousness? Is this the future of humans? Why is this different to AI? Well, basically, does it have consciousness? They're not sure. Why is it different from AI? Well, this is evolution working here. An AI system will be trained on the data it's got and will evolve from there. This is already set. So this is already taking evolution into account when it sets up its neural network right at the beginning of its life. So there you go. Can we apply this to humans? It's a massive magnitude step on from there. There are 86 billion neurons. So therefore you can imagine how many synaptic connections they need to map. So we're a long way away from there. Don't worry. Well, this is maybe the next step. This is the human robot centaur. So these are researchers in China, and what they're trying to do is carry stuff and hopefully make it easier for humans. So one of these little centaurs, obviously it's trying to work in conjunction with the human here. It can boost the metabolic, or can reduce actually the metabolic cost of humans working by 35%. i.e. making it easier, but also it can carry 25 kilograms and it shares about half of that with you. So there you go. Now, obviously, a wheelbarrow will kind of do this as well. But there you go. It's, we've got to do these experiments because you never know, but there you go. Very interesting. So this is really interesting website. There are two really in this one. One is Yoink and one is PlayPhrase. Now PlayPhrase, you go there, it is, you do need to sort of sign up and pay a subscription, but you can play around with it for free at the beginning. So whatever and this is me just typing in stuff in the yellow. So, if I type in what the hell, it then goes and finds out all the videos with that clip in it, which is really, really interesting. So how much do you, and therefore it'll find all of these videos as well, which is really interesting if you're doing little cuts or whatever. Now, copyright notwithstanding, you need to take that on yourself. But there's another website called Yoink, or it's actually an app. You can download it for Windows and Mac. And what that will do is you type in the phrase and it will automatically go and get the clips, but just the audio, and it'll then clip out that audio so you can then just use them as samples. Again, copyright notwithstanding, but two very useful things if you're into that world. This is Google's update on Google AI Studio, and it makes it a hell of a lot more practical, basically, by integrating Firebase. Now, Firebase does all of the back-end really nerdy stuff like databases. It'll do authentication. It'll do multi-user services and that sort of stuff as well. So previously, you kind of had to do all that yourself and then get your API and then, attach it. So this will do it for you. So if you want a database, it will make you a database. If you want authentication, it will do that for you. So vibe coding is obviously the new thing, and this made it a lot more safe, shall we say, in one sense. But then again, if you don't know what you're doing, this has made it a hell of a lot more dangerous as well. So there you go. If you're thinking of vibe coding, but you've always thought it can't do the real gnarly stuff, well, now it can. This is really interesting, again in China, using the ubiquitous Unitary G1 robot, and this is a robot clearly playing tennis. Now you're thinking, okay, that's interesting. It does look a little bit weird the way it's doing it, and it's because of the way it's trained. So it's trained on what they call, which is brilliant because they've called it latent, and they've really tried here. It's learns athletic humanoid tennis skills from imperfect human motion data. So the clue is in that. So basically what they've done is they've used some motion capture, but they've used imperfect motion capture. So, and also it's not just loads and loads of training data. It's just little snippets of people doing a forehand and a rally and all those sorts of things, and a lob and a smash and things like that. So what they've done is they've fed all that in, and what it's then figured out is with very little data and very little coherent data, it's figured out how to actually play tennis. So there you go. It's working. It seems to be playing it pretty well. It can always return the ball, for instance. So what other... I mean, tennis is good, right? Because you don't actually have to interact particularly physically with the robot. But if this was in football or rugby and it figured out how to play that, that might be a whole new dangerous level of sport. So there you go. Kind of interesting. And yeah, possibly the future of sport. This is the latest version. There's a little bit like the fly thing, really. This is the latest version of trying to visualize what's in an animal's brain using its visual cortex. So I'm really into this research, been into it for probably 2 decades now. So this is really exciting. So what this is you're seeing, just to explain it a little bit, is each one of those little stripes, and I've highlighted the stripes across it. So you've got a mouse, and what it was actually showed a video, which you can see in the top blob, and the bottom blob is what they recovered from the mouse's brain. They reconstructed that visual data. So, for instance, if you look at, say, mouse 2 and what is called GT, that's the ground truth, and the reconstruction is the 1. So you can, if you squint, you can go, look, it's not perfect, but what they're actually doing here is they're looking at the cells of the brain, they're pulling out the data from the cells of the brain, and they're reconstructing the video data. Now, what they're doing here is they're actually literally on a cell level, and this is what's new about this. Before you put a mouse or a human into an MRI scanner, looked at their brain, fed them lots of video, and you correlated the two, and therefore when you looked at their brain later, you could try and figure out what the video they might have seen. And this is now looking at a cell level. They're using AI models and all that sort of stuff to do the joining, but this is, this is the next step of detail, basically. So it's very exciting. What will this mean? Well, obviously in the future, then if you are blind, then this may be a way of figuring out how to actually connect the brain together. But likewise, if you want to record your dreams, potentially sell them for money, then this is how you do that as well. And obviously in a dystopian future, this is how law enforcement will get the evidence out of your brain. There you go. Interesting. And we have the PIN number visualization, which is very exciting. So this is a piece of research, and this goes back to 2012 by the late and great Nick Berry, who is essentially a cyber researcher and a security researcher. So what you've got here is all of the PIN numbers separated by first 2 characters, last 2 characters. So on the vertical axis, you got first 2 characters, horizontal axis, you got the last 2 characters. So obviously, if you look at, and the color, by the way, is the popularity of those numbers. So you can see that big diagonal line all the way through. That's because people have chosen double digits. So they've got 10-10 or 50-50, or obviously the big bright one is 69-69, for instance. Now that big blob in the top corner is actually the least favorite one, which is 8068. Nobody chooses that one apparently, or 0.000744% of people choose that one. And the most popular one is 1234. Of course it is, and also 0000. But it's really interesting what you can see here is you can see that stripe going across. So that's the horizontal first 2 characters. So the first 2 characters of a lot of people are 20 something. So obviously 20, and then if you look elsewhere, it'll be 2030, 2021. So people's birthdays or birth years are now being used as their passwords. And likewise, lots of people start with 10, etc., etc. So kind of interesting how you see people's, I guess, birthdays, and also propensity for double characters, and also where the obscure ones are as well. So there you go. Very interesting. Hopefully it was interesting. Hopefully it was useful. If it was, give it a subscribe, and I'll see you again next week.